Okay, we're beginning our study of weather. So, the very first part of this course is just going to kind of explore what weather is, how you monitor weather. So, this week we'll talk about monitoring weather. So, what is that? What are some, if you looked outside or you walked outside, how would you describe the weather? And that's a big part of understanding what we're going to talk about in this whole semester here. So, it's basically a description of certain variables, quantitative or numbers. If you walked outside, you want to know temperature, right? You might want to know how humid it is, how much moisture is in the air. Are there clouds? Is it going to rain, or is it raining or snowing? What's the wind speed and direction? And meteorology is just the study of all these processes. So, climate, on the other hand, is long term. It's weather conditions that you kind of average over a specific time period, usually in the case of the National Weather Service, 30 years. And climatology is even more in depth of study of climate and the Earth's influences on it, the sun's influences on it. So there are numerous ways of accessing the weather. Every day you wake up, your smartphone probably has a forecast on it telling you what it's going to do today. There's other things such as NOAA Weather Radio. I will guarantee you sometimes now get alerts on your smartphones indicating that there's a flash flood warning for your area or tornado warning. And now in the future, if there's a major severe weather event, you're going to be getting those kind of warnings on your smartphone just automatically. So, one part of weather that's interesting, weather is what's occurring right at this moment. In other words, right now, if I looked out the window, that is the weather. Now, if I look out 10 minutes later, that's the weather then, 10 minutes later. Weather is constantly changing. It's never the same. So when I want to look at weather over a large area, I want everything to be lined up exactly at the same time. And the way we do that in meteorology is we use universal time, or basically time at Greenwich, England. So with that, that means that, for example, if it's 7 a.m. in the east coast of the United States, there's a 5-hour time difference with England, so it's actually noon over there. So that noon over there is the same as 7 a.m. here, which is the same as 6 a.m. in Central, 4 a.m. Pacific. But every one of those times would be the same at 1200 Zulu or Universal Time. And those observations at every one of those locations across the world all can be plotted on a map at that exact moment in time to describe the weather. Now, if I plotted an observation that was 45 minutes later, that's not describing the weather at 1200 UTC. So I want all my observations to be at the same time because weather is constantly changing. There are a couple types of weather systems we can look at. Pressure systems, really, high and low pressures. We'll look a little bit more depth at them as you go through the course. But highs are basically generally fair weather and the wind flows around them clockwise. Lows generally counterclockwise. And here you can see that, just a depiction of it, too high on your left and low on the right. Air masses. They're basically large quantities of air that all have similar characteristics. For example, if I have a quantity of air over Canada, covering much of Canada in the wintertime, what does Canada have in the wintertime? It has snow on the ground. A lot of cold. Pretty dry, too, because there's no real water over in the central part of Canada. So what you're getting is an air mass that's very cold and very dry. Now, if I have another air mass that's forming over the Caribbean Sea, well, Caribbean Sea is pretty warm. It's very humid because it's over the water. So that's a different kind of air mass. And where those air masses meet are fronts. And so you have a warm front, just means warm air is advancing towards you. And you have a cold front, means cold air is advancing towards you. Oh yeah, weather is three-dimensional. That means it has a vertical component as well as both the north, south, east, west components. That vertical component has a huge impact on where rain might be falling, or if rain or snow is falling, or even what kind of clouds you're getting. So knowing the three-dimensional, warm fronts, they tend to slope less upwards. In other words, if I was walking in the mountains in West Virginia sometimes, you might actually get above a warm front coming your way and be in the warm air. I have been, when I used to forecast in Charleston, West Virginia, there have been times when Beckley was actually in the warm air, high enough to be in the warm air, and Charleston was still in the cold air down at the surface. So that's the three-dimensional aspect of weather that we're going to talk about a lot. And some fronts do not have precipitation, some do. Coastal areas can get lakes and sea breezes. I live right by the Atlantic Ocean here in southeast Virginia. And there are days when I can go down towards the ocean and the wind coming in off the water can make a major difference in what it feels like. Maybe 5 miles inland, temperatures are in the 90s. Maybe at the immediate beach, temperatures are in the 60s in the springtime. That 30-degree temperature change is all due to the ocean and these sea breezes and lake breezes. So if you were describing the state of the atmosphere, I bet you want to know about the maximum temperature. Guess what? Maximum temperature occurs in the mid-afternoon. And why is that? Because the sun continually heats you all day. It's staying up there and beating down on you and gradually getting hotter and hotter. So even though it reaches its peak at noon, it's still continuing over top of you. So you wind up with your highest temperatures in the mid-afternoon usually. Minimum temperatures are around sunrise. Dew point is just basically a temperature that you cool to where dew will form or frost. We talk about relative humidity, amount of moisture in the air, precipitation, air pressure. We're going to get into every one of these in much more detail. Sky cover. A lot of people love looking at clouds. And then there are different weather watches the National Weather Service issues and warnings. So what are clouds? They're just a whole bunch of tiny water droplets or ice crystals, or even a combination of both. On the left, you have cirrus clouds. Cirrus clouds are wispy because they're made up of ice. To the right are lower cumulus clouds, kind of puffy. Look at how dark they look compared to the more wispy, lighter clouds to the left. Well, that darkness is due to the moisture in them. They have more moisture and they have water in them instead of ice. And fog is just clouds that's basically in contact with the ground. And I know in West Virginia, when I forecasted there, my in-laws still live there. You drive through certain valleys, there's a lot of fog. Stratiform clouds are basically just sheets of clouds. They all seem to be in one layer. They can be fairly thick. And cumuliform clouds are kind of puffy. And when you get the vertical development in cumuliform, you get these thunderstorms, cumulonimbus clouds. And they move in different directions. Why is that? Because clouds, depending on what elevation they are, might move depending on the wind direction at that elevation. And again, weather is three-dimensional, so that means that winds can be different at every one of those elevations. So that can make a big difference. So let's just take a peek at something here a minute. You're going to get to expose yourself to a lot of different kind of charts. And this one is just a radar map. So currently, these are echoes, precipitation, moving northeast across West Virginia, and moving out of the southern part of the area, moving toward the northeast. They're what's left over from Fred. So overnight, you had a lot of precipitation there. One interesting thing, if I wanted to combine that echoes with a GOES satellite image, So let's bring the satellite down a little bit here to CONUS. And we'll look at just basically a visible satellite picture right now, because the sun is up. GeoColor is the highest resolution image I can get. It also looks at infrared, but I'm going to look at satellite right now in terms of right here is what's left of Fred. So now I can take what I looked at on radar and notice it. If I zoomed in West Virginia, it's kind of hard to tell right here. But some of these southern clouds here have precipitation, not real intense. But then north of that, it probably looks pretty high clouds, so more intense. And oh yeah, if you were curious, this is Henri, Tropical Storm Henri. And this is Grace down here. So we have two tropical systems on the weather maps at this time, as well as what's left of Fred, which is dying. But yeah, lots of clouds and thunderstorms down here in the Midwest, down into Texas and all too. So satellite pictures are great ways of looking at where clouds are, where moisture is. So also, here's a current weather map, surface weather map. Every one of these observations was taken at 12Z or 7 a.m. Eastern Time. And notice, you're going to look at these station symbols. What they are is the weather plotted for that location. And you're going to get kind of familiar with that. We talked about low pressure systems. Here's one. What's left of Fred. Counterclockwise winds. You have south winds here, northwest winds over here. And we'll talk about air masses. And here is an air mass coming down. There's a cold front right here. Temperatures are actually in the 40s up here in Canada right now. So, and on the other side of it, temperatures are in the 70s at this time in the morning. So that's quite a change. And here I just wanted to give you a quick look kind of at a station plot. So if I was looking at this station plot, and this is Parkersburg, West Virginia. Temperature is the upper left. Dew points are the lower left. So that 71 degrees and a dew point of 69. So if the temperature cooled to 69, dew would form. See the collar in the center? It's all shaded in. That means it's cloudy. And here's the atmospheric pressure, 129. Well, we abbreviate by either putting a 10 in front of that or a 9 in front of it. If it's under 500, typically it's going to be a 10. So this would be 1012.9 millibars, just a pressure reading. If it was above 500, you'd add a 9 in front of it. It might be 959.9 millibars. And the 4 dots represent heavy rain. The dots are all rain symbols, and if you had 2, it would be light rain. If you had 3, it would be moderate rain. 4 is heavy rain. These wind barbs, we'll look at one over here. It's a little easier to see. They show the wind direction. And here, it goes from southeast to northwest. And for a meteorology perspective, that's a southeast wind. It means the wind is blowing from the southeast towards the northwest. And if I'm stating a wind, I'm saying it's southeast. And as part of that, then, I'm looking at the barbs. Here's a little tiny one. That's 5 knots. Here's a bigger one. That's 10 knots. So these are the barbs that point in. And here again, you can see the rotation counterclockwise around this. There's a big high pressure system out here off the United States that has a clockwise rotation around it. So hope you got something out of this week. If you have any questions, please do not hesitate to ask me.